Please join us for In the Works, a weekly update of public works projects for the City of Kingsport.
Hi, my name's Ron Haynes. I'm the lab tech here at the water treatment plant for the City of Kingsport. I test the water in pretty much about every aspect. I'll test it when it's still in the river. I test it as we're treating it here at the plant, and I test it out in the distribution system. So I'm here to talk a little bit about water quality and what it means to you. People generally don't think a whole lot about water quality. I mean, it's not the main topic of conversation when friends get together. However, I think more and more people are taking note of the water and the role it plays in our society. Historically, water played a real significant role in the transmission of some really deadly diseases. Cholera, typhoid, hepatitis, a lot of gastrointestinal diseases. So that's why we're here. We're here to make sure that doesn't happen again. It's kind of a task to take water from the river and treat it physically and chemically and turn it into a safe, potable water supply. The City of Kingsport is very proud to be able to produce a product for the citizens of Kingsport that is not only safe, but it's great tasting and something they can depend on. As a matter of fact, the city's been doing that since about 1929 anyway. And the employees here at the plant, I'd like to speak a little bit about them. You've got about 8 operators here at the plant. All of them are certified by the state of Tennessee. They're trained operators for plant operations. But as good as they are, there's one thing that you cannot teach these operators, and something that they all have in common, that they really care about the quality of water that leaves this plant. They're very good, and that alone makes me feel a lot better about drinking the water. The maintenance staff here, we're blessed to have a good maintenance staff, a good capable bunch of guys that keep this place going 24 hours a day, 7 days a week. And they are on call pretty much all the time. When something breaks down, they're here, and they'll take care of everything from the computers here to the tanks out in the system. We have to keep the water out in the system fresh and maintained for our customers at all times. That means manipulating the tanks to make sure the water stays fresh inside those, keeping as much water as we can in there without compromising any kind of quality from water sitting in the tanks too long or something like that. So that's important too. It's pretty much, it takes everybody here at the plant to make a good, safe, potable, great tasting product, and we all do a pretty good job of it here. Since I'm the lab tech and I see about every aspect of it, I'll show you a little bit here in just a moment about what we do. Here in the lab, I run a variety of tests on the water, everything from hardness, alkalinity, turbidity, chlorine, out to trihalomethanes, haloacetic acids, volatile organics, things like that out in the system. So there's a lot of tests go on here, and one of the tests here I'm going to do for you is the total hardness test, which is a combination of the calcium and magnesium ions in the water. Now this will show us an end point when it turns a different color using a digital titrator, and that's how we will figure out the total hardness in the city water. I run this on the raw water and the water that goes out into the system. So it just takes a minute to start turning, and we're about there. Yep. And now that will tell us, using the digital readout, exactly what our total hardness is of the water. Color change is a large aspect of many of the tests we run here in the lab, so it gives us an endpoint, tells us what our numbers are supposed to be. we are at the South Fork of the Holston River at the city's water intake. This is the pump house. We pump about 15 million gallons of this water a day over to the plant via the pipes and the pumps you can hear in the background. As you can see, the water coming down the river is pretty clear. It's pretty free of debris. We're located about a mile down from the Fort Patrick Henry Dam and about a quarter-mile upstream from the Eastman Chemical Company. So not only is it the water clear, it's a beautiful area, and we're lucky to be blessed with this kind of water. Even during a drought, we have about 6-7 dams upstream that control our water system. So even during dry times, we have an ample supply of water. I'm out here standing beside one of our settling basins. As you may have guessed, when you bring water in from the river, it's not exactly ready to drink yet. That's why we've got the water treatment plant. So we bring the water in, we add chemicals to it, and one of the processes is a settling basin, and that's where I'm at. And what happens is the chemicals added to the water comes in from the upper end up here. The particulate matter is settled out, and as the water flows down this way, its particles settle out on the bottom, and then the rest of the water comes over the weirs and goes into the filter hall where it's filtered. Now, before this process, we add different chemicals. We'll add a coagulant, we'll add chlorine to kill bacteria, and after the process and after the filtration, we add the fluoride. I'm standing here beside one of our 12 filters at the water treatment plant. Inside these filters is sand, anthracite coal, and gravel. Now, these filters are rated to filter approximately 4 gallons per square foot, which is quite a bit of water. And what the filters do is they'll take out any particulate matter left over from the sedimentation basins. And so what gets caught in here gets backwashed out every 72 hours. But after the water goes through this filter, it's ready to drink, and that's what's sent out to the system. Here we are in the control room at the water treatment plant. As you can see, we have computers set up, large screens, so the operators can keep an eye on the process of the water everywhere it goes through. Right now, you can see we have a screen that shows our water tanks out in the system. The operators will manipulate the amount of water in these tanks to keep a fresh supply to the customers. It's very important, believe it or not, because the longer water sits, the warmer it gets, and it can change characteristics. Over here we have a computer that shows finished chlorine, the turbidity, the settled chlorine, raw turbidity, basin turbidities. We've got pumps. We can control everything about the plant, this pump house, and the pump house at the river from right here in this control room. And then we have a screen that shows the filters. And each filter, it tells us how much water, how many gallons per minute are going through, and the turbidity of each filter. So as you can see, the control room is a very important aspect of the water plant, considering this is where the operators stay here 24 hours a day, 7 days a week, keeping an eye on your water to make sure it's good.
Hi, my name is Jason Starnes. I'm a distribution specialist with the City of Kingsport Water Department. Today I'm going to talk a little bit about water quality control. We all expect clear, clean drinking water every time we turn on a spigot, but what does it take to keep our drinking water safe, clean, and clear? Basically, everything begins at the water plant, but once it enters the distribution system, it has to be protected in the quality control. The City of Kingsport has over 900 miles of water mains that must be protected and controlled. We accomplish this by a proactive cross-connection control program and a routine flushing program. We're standing here today at the V.O. Dobbins Center, and behind me are some backflow assemblies. These are part of our cross-connection control program, and they're part of the protection of the water. We do have an active and ongoing program for finding and eliminating actual and potential cross connections. A cross connection is any physical arrangement, actual or potential, that connects the public supply to a source of unknown quality, which could contaminate the public supply by means of backflow. And backflow is the reversal of water. These assemblies protect against back pressure and back siphonage types of backflow. Back siphonage would be a customer has a pump installed on their water line, creating a higher pressure than the supply pressure, or a multiple story building, which would also create higher pressure on the customer's line than our supply. Back siphonage would be created through typically either a main water line break or fire line usage. And an example of that would be a garden hose submerged into a swimming pool or a bucket. If the main line was to break or fire hydrant was to be used, it could potentially, through vacuum and back siphonage, pull the water out of that bucket or swimming pool. We actively survey our system for cross connections, and upon finding them, we eliminate them by either means of an air gap or an approved assembly such as these. Every assembly is then further tested and re-inspected annually. Currently, we have 2 full-time testers who test and inspect over 1,900 backflow assemblies every year, and they're actively surveying for more unprotected cross connections. Okay, what we have behind me right now is this one right here is called a double check detector assembly. This is a smaller version of a double check assembly, and this is a reduced pressure zone assembly. And the difference in them is this little discharge right here. This one right here is our highest level of protection. We require it on most commercial, industrial, irrigation type of installations. This one right here is good for fire line usage, something where the main concern is going to be chlorine, not necessarily a contaminant, major contaminant. When one of our flushers comes out and opens up a blow-off, he's checking the water for clarity and also for chlorine content.